Good afternoon, everybody.
Good afternoon, sir.
I expected there to be the 4 people more. So okay, one more has joined. Another 3. Um, Anybody from HR joining? I have no idea. Do you know who the other 3 people are who are supposed to join? Okay, 2 more.
Hello.
Yes.
Good afternoon, sir.
Good afternoon. I am expecting one more, at least.
नहीं उधर हो चलो.
Any idea? Are we expecting the others to join, or this is it? I had a list of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I see here only 10 present. Any idea who the other person is amongst you? Okay, I'll just Milind Gaur is there. Bhavadarni Kennedy. Anybody knows her? Okay, Vishal Goswami is there. Bharat Kandipu. Bharat is also not there. Then Saurabh Ujjwal is there. Shruti Mol
Hello,
Mani.
sir. Hello.
Shruti Mol Mani.
Hello.
Yeah, please. Who is that?
Yeah, Bharat is there, sir.
Okay, I know. I can see that. But okay, Shruti Mol Mani has not confirmed. Okay, Shreya Bakshi. Shreya Bakshi, yes, she's there. Kalyan Datta, Suvajit, Dr. Nadeem. Okay, I think one of them has said no to this meeting. Fine. Okay, I am surprised. Okay, now can I request one by one for you to please open out your video, introduce yourself, since I don't know any one of them. Let's start by an introduction. Take no more than 1 or 2 minutes. So shall I call out the name? That would be better. Or you want? Okay, Milind, you can start.
सर मेरा नाम मिलिंद प्रताप सिंह गौर है। मैं नवी मुंबई सूप में ट्रेनिंग इंजीनियर के रूप में ज्वाइन किया हूँ। अभी मेरा को डिजाइन इंजीनियर का पोस्ट मिला है।
Where are you from? In the sense, which? What's your
सर मैं
hometown?
रायपुर से, सर मेरा होम टाउन रायपुर है।
Okay.
रायपुर छत्तीसगढ़।
रायपुर छत्तीसगढ़। ओके, और कौन से कॉलेज से ग्रेजुएट किया?
सर मेरा ग्रेजुएशन हुआ बीआईटी दुर्ग से, भिलाई इंस्टीट्यूट ऑफ टेक्नोलॉजी दुर्ग, और मेरा मास्टर हुआ है वीएनआईटी नागपुर।
वीएनआईटी नागपुर से। ओके, राइट, थैंक यू मिलिंद। कैन सुकल्यान सरकार स्टार्ट नेक्स्ट? ओपन योर कैमरा प्लीज एंड by the way, do you all know each other, or you're in? I know you're in different offices, so just a general question. You may be knowing one or two of you in your own office, but so it's good idea to get to introduce to each other. Yes, Mr. Sarkar. Hello. Hello. Okay, we'll move on to Saurabh. Saurabh Bhujbal.
Hello, sir. Sir, I have joined
Don't-
from the desktop, so I don't
Okay.
have the camera.
Oh.
Yep.
Okay.
Since last 2 years, I'm working in Stoop. I have completed my MTech from VJTI.
ब्रिज कर
From last year, since when I joined, I'm working on the workshare projects that we're getting from the Saudi Arabia. So basically, I have experience in Ashtopol.
Mhm.
And I'm from Maharashtra only, and I'm working in Mumbai office.
Okay. Then Nayana Muniappa.
Hello, sir. My name is Nayana. I'm from
You
Bangalore
have your
office.
camera on? Camera, can it?
No, sir. Even I have joined from my desktop. Next time I'll make sure I'll join through a laptop.
Okay, right.
Okay. My name is Nayana, sir. I have completed my master's in structures from Ramaya Institute of Technology. I'm from Bangalore, sir. It's been 2 years I've been in Stoop. I'm into major structures, sir. Especially I'm into railway structures.
Okay. Then Suvajit Datta. Your screen is dark. Right.
No, sir. Good afternoon, sir. I'm Shuvajit from Kolkata. I have completed my master's from NIT Durgapur in 2021, and I've joined STUP just last year. And I've been working on road bridge projects, specifically Satragachi Salimar project and other projects.
Okay. Next, Shreya Bakshi. I met with Milind Gaur has introduced. Shreya Bakshi, please. Hello. Hello. Can you hear us, Shreya Bakshi? Okay, I'll catch up with her later. Okay, Akhtar Nadeem. Hello. Nadeem Akhtar. Okay, not responding. Praful Prasad.
Good evening, sir. Good evening, sir. I'm Praful Prashad, and I'm from Gurgaon right now. Like basically, my hometown is in Himachal, but right now I'm in Gurgaon system office. And I've joined LNTIL last year as the PGET. So yeah, right now I'm working here.
Okay. Bharat.
And I'm from NIT.
Where which college?
NIT Jalandhar.
NIT Jalandhar. Okay, right. Bharat Kandepu.
Good evening, sir. I'm Bharat. I am basically from Andhra. I joined LTIL before last year. It's been 2 years I'm working in IEL. Recently, I converted to STUP. So I am working from Hyderabad office here.
Okay. Vishal Goswami. You're muted, I think. We can't hear you at all. You're not audible. Not audible. Now it is audible. Hello? Can you repeat? I can't hear. Oh, okay. You have. No, 1 second. So I have the video on of Vishal Goswami. I can't hear you at all. Okay. Hello? Absolutely. I think you have to. Not audible at all. Okay. I have feeling those of you who are having some technical issues with connectivity, please contact your IT personnel, because I want this whole program to be a lot more interactive than me talking and you listening. For that, in that case, it is easy for me to finish the course and say I recommend the following books. You read it. That would be easier, right? The choice of words, the description, the explanation will be far better than what I gave. So get this thing sorted out. And a few of you who have not been able to connect, we'll catch up a little later, maybe in the next. Who is that? I wouldn't know from. I am not familiar with the face and the voice yet. Can you switch on your camera, please? Okay, fine. Right. Okay. Then a brief introduction of yourself. No problem. Are you able to see the presentation then? If on the okay, you're on Teams, so Teams. Yeah. Okay, fine. Okay, go ahead. Okay. What Institute of Technology? Heritage. Where is that? Okay. 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 Right. Okay. And what are you working on in Calcutta? I presume you're working in Calcutta office. Okay. 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 Right. You have all introduced yourself. Let me give you a little brief about myself. And so, my name is Venkatram, and I have a much older connection with Stoop than all of you. My first major job after finishing my postgraduate was in Stoop. I was working in the Bombay office from 1984 till 1994. So you can say that is where I cut my teeth into the so-called hardcore engineering design of all kinds of structures. While in Stoop, I had carried out designs of bridges, cooling towers, chimneys, TV towers, and cooling towers, both natural draft as well as induced draft, and also worked on aqueducts. So I had a very wide range of structural involvement when I was in Stoop, Bombay. I worked there for 10 years. Then I left Stoop and went to work for 6 years in Malaysia. There, I worked with a consulting organization, primarily designing bridge structures, and I was the head of bridge department there when I quit and came back to India in 2000. In 2000, I joined L&T Ramboll in Chennai, and uh, it has seen multiple ownership. That same company, I have been continuously working in. The organization is the same, but it has had many names. From 2000 till 2014, it was called L&T Ramboll Consulting Engineers, a joint venture between L&T and Ramboll. Then in 2014, L&T bought out Ramboll's share in the joint venture company and made it a wholly owned subsidiary and renamed it as L&T Infrastructure Engineering Limited. Then from 2014 till 2023 end, 24 beginning, it was L&T Infrastructure Engineering, and then in 2024, now L&T sold whole of its stake in L&T Infra Engineering to Systems, and they have renamed it as Systems India Limited. So I joined in as a design engineer in Stoop in '84, just after coming back from US with my master's degree, and I rose to be what was, I don't know what's the designation now in Stoop. In those days, it used to be called associate principal consultant. I don't know what its equivalent now is there. And when I joined L&T Ramboll, I joined as a senior project consultant and rose on to be the chief executive from 2011 to 2019, when for personal reason I wanted to cut down on my workload. I requested the management to relieve me of my responsibility as chief executive, and then they made me chief technology officer, and I kind of continue in that role, but with the diminishing commitment to the company, and now I am advisor. So I graduated in civil engineering from IIT Madras in 1981 and did my master's from Carnegie Mellon University in Pittsburgh, USA between 82 and 84. So that's the background I have. None of you, I want all of you to take one thing. You can be relaxed. There is, I don't hold for any formalities in the sense that, and everybody calls me by my initials PGB from my days in the Stoop. So it has stuck with me even after I came back to L&T Ramboll and L&T organization. I am still known by my name as I was known in Stoop Bombay. So you can also refer to me as PGB. There is, I strongly request not to hold on to any formality, not to keep in mind whatever designation position that I have held in this company then and now, and look at me as somebody who is there for helping you grow technically. So I have been looking for some kind of a meaningful engagement for the last 1 year. So finally, in the wisdom, the management has decided to hand over your technical, I don't like the word upgradation, but essentially to make you a lot more involved in the projects that you do and also become more competent. So ultimately, at the end of the day, I will make it very clear. I can only introduce the subjects to you. How much you learn from it is up to you. So I would strongly, the reason why I wanted the cameras on, it gives me an indication that I'm not talking to a blank screen and well, all of you others are engaged in whatever you're doing. But considering the bandwidth issues, I don't mind the cameras being off. So with that, we will start the whole session. You may have been briefed on what the course is. This is actually, to give you a little background, I conducted this course. I forgot to tell you one more thing. Since 2020, September, I am also faculty in IIT Madras. So I am a professor of practice there, and I don't do any full-time course, but when required, IIT Madras hands over certain courses for me to conduct for their master students, as well as some other program that they conduct. So this program was structured for me to conduct in the year 23-24 for a batch of 15 engineers from L&T who were part of a postgraduate bridge engineering diploma program uh, being offered by IIT Madras specifically for L&T engineers. So this is one among the 5 courses. To be honest with you, the other courses are all a lot more technically involved, but this is more like an introductory course, and that's why it's titled Introduction to Bridge Engineering. So we will cover the whole spectrum of um activities that we do when we carry out bridge design. So that is how this course is structured, and I have roughly estimated that it will take about 6 to 8 months to cover this whole program at the rate of one session per week. I used to take it over 2 sessions in the per week in the earlier days, so that it was over in about 4 months. But here, because we have uh, time available for only one session per week, and on my request, it has also been increased from original plan for 1 hour to 2 hours, so that we have some amount of interaction time. And in between, there will be also questions. And in this 8 months, I propose to give you all some individual assignments, which I want you to do. It will not take much of your time, but it will require you to work independently. And I want the assignments, when I give them, to be handwritten. I don't want them to be typed. I want them handwritten. Then you can scan it and you can convert it to PDF and submit for the evaluation, so that there will be a continuous evaluation. I don't want to emphasize the fact that this work, I want you to be as independent as possible. Take all the help you have, and rest assured that none of these assignments are something that is going to take too much of your time, but it will test whether you are able to understand and do the work independently. So that's the rough background of how this whole thing is going to get structured. So with that forward, I will start this program, and let's hope we meet each other. I have one strong request to all of you. Please make sure that you are at least a minute or two ahead of the time, rather than a minute or two after the time. This is a life lesson. It is not a technical issue at all. What I am like to tell you is that the moment you give value to other people's time, it will reflect on the fact that you give value to your time. And if you give value to your time, just like you don't like to get it wasted by anybody else, you also respect other people's time. So my strong suggestion to you, whether it is this class, this session, or any other official and formal commitment, be there a few minutes ahead and not a few minutes later. Okay. uh, I don't like to emphasize this again and again, but being all professionals, I think it's a small courtesy that we should extend to each other. So I don't want uh, the next session to start even a minute after 4 o'clock. Let's be there a few minutes before and log into the system, and uh, let's have our interaction. All right. So we will start this whole process by understanding what is our aim for this accelerator program, as it has been termed by the organization. I will share my screen with you. In case you are unable to see, please uh, Let me know if there are any issues with it. Are you able to see my screen? Okay.
Yes, sir.
Right.
Yes, sir. Yes.
Now, as with any learning program, you can look at it as learning, you can look at it as interaction, but I want you to be very relaxed about it. Okay. Any doubt, whether it is on a subject of the day or whether it is on a issue that has been bugging you, for which you think a set of second head giving you some ideas is there, it's go ahead and please ask. Okay. And that asking attitude approach is what is emphasized in this small correlationship in any upgradation, any competency that you want to develop. You will have the involvement of heart, hands, and head. And heart part of it is where it comes with your attitude to learning. Can I take a quick oral count? I have 10 people attending. You can all tell me how many of you spend reading technical material outside of your office hours. Say yes and tell me roughly average how many hours per week. Quickly, one by one. Silence would mean something else to me. Okay. So, how many of you manage to spend any time in technical reading outside of the office hours? Huh? 5 to 10 hours a week. Okay, that is Shukalyan. Others? Silence. Shall I assume that it is none? See, there is no point in feeling bad about it. It's a way we have all set our lifestyle. Okay. Anybody else has anything? So let's assume that we are on near zero time on our technical studies after office hours. What does it tell us? I'll give you a small uh, parallel example. If you can visualize somebody like Roger Federer, he was one of the greatest tennis players of all time. He goes and plays championship tennis, and after he finishes the uh, matches, which is his professional work, he earns money out of that. Does he go home and hang up his rackets? Never touch them? Does he? No, no. He goes back whenever he has free time. Certain amount of time he allocates to continue to practice, and that is what makes him the professional he is. How he was now, of course, he's retired, and the professional that all of us can aspire to be. Which means what we have to invest time on ourselves. Company will go only so far. All organization, doesn't matter whether it is Stoop, a system, XYZ, L&T, this, that, doesn't matter. All of them are willing to only spend so much time on your personal professional growth. They are looking for more as an organizational growth. So somewhere along the line, if you have to align yourself, you need to spend some time for yourself on your professional growth. If you don't do it, well, eventually the losers will be all of us. Okay, so that's the first part. That to get into the skill development, we need to have the attitude part, and attitude comes from the heart. If you have the heart, you will generate the necessary time for it. If you don't have the heart, no matter what you do, you will not be able to spend any time. Okay, after the heart, we need to build up skills which are involved with the hands. In our case, the skill would be use of the software, use of the modeling, use of the analysis tools that we have. And finally, the most important of all, the head part of it. And the head part of it is knowledge. And this is linked, this is where you need to have the right attitude to get the right knowledge. And when you join all these three together, you end up into the mode called asking mode. That means you will, when in doubt, you will first ask. Of course, first try to learn on your own. If you can't, you ask. Even if you learn on your own, you can ask to evaluate whether what you have understood is right or wrong. So all of you need to find partners with which you can have your with whom you can have your exchange of ideas. What they call bandy your ideas around with each other, evaluate it, and then take a right choice. Because in all our engineering design work, we are essentially making a choice from multiple options. So sometimes our choice is right, sometimes our choice is bad. All of them may be safe, but when I say good or bad, it depends upon their efficiency, applicability, economics, and things like that. So in all these things, we need collaboration. So at this time, never hesitate to ask. Okay, that is why uh, in all learning exercise they will tell you when in doubt, ask. Okay, so develop that. When you do that, your learning will automatically improve tenfold. Now, in all our career paths, we have seen these. All of you are today team members, but at one time you will all be team leaders, and one time you might even be reaching the organizational leadership. In all these things, the attributes that you need to have with you is as a team member. Currently, you're all trying to be achievers, but eventually, all of you must develop the attributes of being passionate about of your subject, and that would be a characteristic you will notice all team leaders. Whichever team leader you meet, anybody whom you admire, anybody whom you think has done professionally well, you will find a certain passion for the subject from their side. This is something that you all need to develop. It's an individual choice. You can do a little bit, you can do a lot to grow this. And once you have from achiever to become a passionate practitioner, you will find that you are automatically going to become the team leader. The organization is willing to spend some time on you, time, effort, energy, cost, whatever you want to call it, but it's up to you to make best use of it, and a lot of it depends upon how you approach the whole thing. I would like to share with you certain thoughts. I strongly believe that those who adopt a philosophy that after the college studies I have passed all the exams, and therefore I have nothing more to learn from any source of knowledge, I can tell you that kind of an philosophical approach will lead to a stagnation. You must be in constant search of newer and fresher knowledge, newer and fresher understanding, newer and fresher approach to all activities that you do. If you keep that intact, you will find professionally also you will grow, and personally also you will grow. Okay, right. So, what we will do is we will start this introductory course with understanding of the evolution of bridges and what prompted the changes. We'll start with that, and eventually we'll go to the complex subjects about design, analysis, detailing, and mostly at the concept level. Rest assured, I will not take you to intricate mathematical formulation, which will put you to sleep and also will possibly test my own personal knowledge of that level of mathematics. Okay. So as you can see in this picture, our simplest of the bridge forms were normal slab type. Then we migrated to girder and slab type. Then we went to the box type. Then we had truss type. We have arch type. Then we had integral type. Then we had cable stage type. And then we had the suspension bridge type. What is more interesting to us is why did we progress? Why did we progress from the simplest to the complex? What prompted these changes? This is important thing for us to understand how our field of work has evolved and how it is likely to progress in future. Because ultimately, so for somebody like me, I am at the tail end of my career, and for like all of you are at the beginning of your career. In the sense, my 40 years are over, your 40 years have just started. Okay. So in that sense, what you see in the past is what will be a reflection of what is likely to be a path of nature of the path that is likely to be in the future. All right. So let's look at what prompted the changes. So looking back at it, let us divide the whole history can be divided into about 5 periods. You can call one prehistorical, then the classical period from the BC, AC, what a Christian era, CE as they call it nowadays. Maybe I have used the wrong, what do you call it, abbreviations. Modern day they use BCE and ACE, that kind of a thing. So then you have Middle Ages, early modern, and modern. What we are living today in modern. What after a few years, by the time some of you reach my age, then you will be giving a similar lecture to another form, and then what we have done, what you are doing now, will become early modern, and possibly there'll be postmodern, that you can call it, will come up at that time, and you can talk about it. So these 5 historical eras we will cover in terms of what's happening, what prompted. We are looking for a change from simple forms to the more complex form. Why did we migrate? Okay. Among the prehistorical bridges, most of them were naturally created. Naturally created means no human intervention was involved in it. And an example of it is the desert of Wadi Rum, Jordan, where you can see a naturally eroded structure which gave an idea how an obstacle could be crossed by a material which will allow human beings to go across the valley or the obstacle. So this gives an idea. Most of the prehistorical ones were not man-made; they were naturally occurring one, and something which, in the form of what do you call it? You can call it as a semi-man-made, naturally occurring arrangement which has been improved upon by human beings with the bridge in Taiwan. Then comes to the classical age. What happened from the prehistoric was only an idea we got. In the classical age, we understood proportion. We did most of the engineering in those era from what is called as a, you can call today as gut feeling. Okay. Load transfer, force, etc. They were not very, those terms were not defined yet. The forces, stresses, strains, they didn't have those concepts in the classical. What are we talking about classical? We are talking about 0 to about 500 AD. In that period, most of which was replicating the naturally observed structure in a man-made fashion. Okay, in a man-made fashion. So the one of the earliest example is the aqueduct here in Spain between 2027 BC and 14 AD. In that period, man-made structure which is still visible and more or less intact, may not be functional. And the same was to carry water from one hillock to the other hillock. Then in the Middle Ages, we came to more functional come recreational bridges. So in a city like Venice, you see a lot of them like that. You can see that it's a bridge which allows access from one shore to the other shore of the water body. At the same time, it allows for a recreational activity to be carried out from the bridge, not so much for transportation as for recreation. So this is one of the types of structures that were built in the Middle Ages. And actually, in the early modern time, and if you look back at it in Middle Ages and the early one, we ended up only naturally occurring material. The only thing we added artificially was the cementitious material. And cementitious material, when I mean, they were not cementitious of cement of today's era. They were more using lime and other things which they discovered, I wouldn't want to use the word invented, they discovered it as an action that leads to the hardening of it, mixing lime with a few other naturally occurring material, which after some time when you mix with water, it becomes hard. And they used that as a cementitious material with other natural materials such as timber, stone, masonry, and things like that. So that is how the material was. The first significant change came when human beings invented iron, and in this case, particularly cast iron. And what they discovered with the cast iron, uh, can any one of you tell what's the distinction feature of cast iron? Engineering property of cast iron, which made it a suitable material for bridges. The earliest material for using in a bridge. Huh? Cast iron. Are you sure? I asked cast iron. I did not say cast steel. I used the word iron for a hint. Anybody else? Which engineering property was identified with cast iron? Or today, what do you know about? Let me put the other way around. What aspect of cast iron is not good as an engineering material? I wanted interaction. People are all keeping silent.
Sir, corrosion or brittleness?
What did you say? First one?
Corrosion.
Corrosion. All iron and steel corrode. Second one, what did you say?
Brittleness, sir.
Brittleness. Yes. Cast iron they knew was brittle. So if it is brittle, then I'll ask the first, who was the first gentleman to answer?
Milind.
Milind. So if brittleness was a property, do you think it is good intention?
No, sir.
In 5 minutes, you change your opinion. So if it was, they knew cast iron was brittle, what did they find? They actually found that it is good in compression.
Yes.
It's good in compression. So what did they do? Whatever bridge form they made sure that all that it would do was it would have been compression. That is what is the sign of the early modern ages when the cast iron was invented. You will not find that they will all be in, they will try to attempt a structure which is significantly in axial compression. Of course, they did not understand the concept of bending and all that much there. Most of the bending were taken from rule of proportion only. Okay, so this is the first modern intervention in bridge construction, the invention of cast iron. So the earliest, one of the earliest bridge, 1779, as you can see from this. Subsequently, the structural mechanics aspect started to get understood a little better. It started to become little better, and also the fact that one started to start manufacturing, I should say manufacturing, graduating from cast iron to steel. So when it came to steel, what did they end up getting? A material that is not only good in compression, under certain circumstances, it's also good in tension because it has got what? Opposite of brittleness is what? Ductility. So because of this and also better understanding of the structural mechanics simultaneously that grew, it became possible for them to build structures in which the force flow and the load transfer mechanism became an integral part. So tension and compression they started to understand, and therefore the steel bridges started to make. Please remember the first one was an iron bridge. From iron bridge, it got upgraded in next 100 years to being steel bridge. Okay, and they also started to take much heavier load. like a full train load was possible to be moved on such bridges. An example of an early modern bridge was in the same period, we had not reached the steel usage in India, but definitely we ended up using a lot of arch bridges, most of them stone masonry arch, because India had a lot of good quality stones. Now, uh, how familiar are you with the availability of materials in different parts of the world? You're all familiar with the usage of concrete, right? Yes or no?
Yes, sir.
Okay. What type of aggregates do we use in making concrete? All are stone. I said what type of stone? What type of aggregate? What type of stone? Okay, if I want to correct the question. Huh? Gravel is size of the related to size of the stone rather than the nature of the stone. I wanted to know what is the nature of the stone used in concrete production in India, or any project that you're familiar with that you have seen.
Granite.
Okay, what else?
Metamorphic. Igneous.
Don't go for complicated words. Granite is simple. There's another simple word. Another simple type. I should use the word simple type. Simple. Another simple type. Granite is one. Yes. What are in India?
Igneous rocks.
Oh, that's a common term. Granite is an igneous rock. There's another igneous rock. No. Limestone is a metamorphosed stone rock. That means originally it was something else. Under high pressure, it has become hard. So, but another igneous rock. You're not aware of other igneous forms in India?
Basalt.
Exactly. So, Indian aggregates, most of the Indian aggregates are what? Granite and basalt. Now, if I were to ask you, I gave you the tag Indian. So, if I were to ask you, what's the most common aggregate in England, where concrete was England, France, Germany, Switzerland, USA? What do you think was the aggregate they used in that concrete? Do you think concrete was invented in India? Hello? Hello? What happened? Where was
Hello.
concrete invented?
Portland.
Which region of the world was the first engineering concrete invented and used?
Portland, sir.
No. Portland is cement, yes. No.
Was it the
See,
Roman Empire?
no. See, I agree they use cementitious material. I said modern engineering concrete. No. Uh,
Then it should be India only, sir.
oh, not at all. Then you mean to say Mr. Neville, who wrote a fantastic textbook on properties of concrete, was an Indian?
England?
Possible? England, France. France comes to your mind? No, France doesn't come to anybody's mind. The earliest scientific usage and definition of concrete came from France. They were the pioneers in. That's why, if you notice in Europe, the French concrete utilization is the best understood. Okay, why I wanted to make, if it was in France, what kind of aggregate they were using? Come on, take a guess. You're all scared to take a
Sir,
guess. Don't worry.
Sir,
Don't worry. I am not going to come and beat anybody up if you make a wrong guess.
सैंडस्टोन होगा क्या?
Huh? Yes. Limestone. Most of the early concrete was made using limestone as the aggregate. So that was the natural material. Whereas in India, we have much stronger stones, which we generally use granite and basalt as the aggregates. So point to ponder. Point to ponder, I want you to think about it. Do you think the properties of concrete, which we use so left, right, and center, adopting from all the various world standards, are strictly applicable if we keep changing the aggregate type from limestone to granite and basalt? That's one question to ponder. Okay. Second question to ponder is, you might have heard about the uh, uh, alkali aggregate reaction, correct? Alkali silicate reaction. You have heard of it?
Yes, sir.
Yes. Do you think it's critical for Indian concrete? Why? Alkali silicate aggregate reaction came about only when you start using limestone as your aggregate. That's when it becomes a critical issue. Can you understand why? In concrete, most of the strength binding product is the uh, reaction between, or some kind of a chemical reaction between uh, silicon dioxide, which you can say sand, and calcium oxide, which is made present in the cement. Now, in the case of limestone, its basic chemical composition is what?
Calcium.
Calcium, definitely, but not as calcium. Limestone is not calcium.
Calcium carbonate.
Calcium carbonate. And what is the one of the important component in cement?
Yes. Silica.
That is true. Silicon dioxide is there. Calcium oxide. And how do you think they get calcium oxide in cement? No. You didn't get my question. How do they make calcium oxide in cement in a cement plant?
From lime.
From
Lime.
what lime?
Limestone.
Limestone. From calcium carbonate, you strip out carbon dioxide, and what will get left is the calcium oxide, which is part of the cement. So limestone itself contains one of the component of the which needs to what do you call it, combine with silicates to form the calcium oxide silicate compound, which is gives the strength. So now if you have a aggregate which has a significant component of the base material for calcium oxide, you have a potential for the aggregate itself reacting with silicates in the cement, correct? But if you don't have calcium, do you have calcium oxide in your basalt and granite? No. So therefore, you don't have to worry about aggregate silica reaction problem in Indian concrete. Okay. See, these are all information which will help you take a decision. Just hold on 1 second, please. I need to take a call. Just 1 second. Sorry about that. Okay. So therefore, you have to, I mean, I introduced that subject only because we picked up a lot of our engineering knowledge from Europe. We have certain things which are advantageous to us. Keep that in mind. Okay. So though, so we end up using our harder rocks for making this arch bridge. It is early modern because it is in that era that we have built. But strictly speaking, it is not classified under. Finally, when the steel became available to us, then we became, and also our structural mechanics understanding improved a lot. As human beings, we started to venture out and make more and more complex structure. And one example of this is an 1884 railway viaduct in France, which is essentially a spandrel arch bridge, and you does this bridge remind you of a recently built new bridge in India?
Chenab, sir.
Absolutely, that's also a spandrel arch bridge, but the construction technologies were much different. So you can see the forms which were kind of created when our understanding of the structural mechanics and the mechanics of material improved haven't changed much. Only the newer material, newer construction, we'll see that as one of the reasons for transition. So we are gradually moving from natural material to semi-man-made material to more or less 100% man-made material as we reach the early modern time. And this is the fourth bridge. This fourth is not the English word for, not 1, 2, 3, 4. It is called the fourth bridge, and it is not based on number. And you can see that there are an oldest steel bridge, railway bridge, and then you have behind that suspension bridge. And incidentally, the suspension bridge has undergone significant deterioration. That road bridge has been replaced by a parallel cable stayed bridge, and for which at least all the approach spans were designed in our offices here in Chennai between 2008 and 2009 when we were L&T Ramboll, for the third bridge, and it is also called the fourth bridge because the fourth is I think there's something to do with the water body as it's called in Scotland. So the structural mechanics principle and all the other design modernization that we ended up having, and as we come to the early part of the last century, we had a lot more fantastic structures designed and built, including this arch with suspenders for an intermediate deck in Sydney, Australia, and then we also got this arch bridge in France with concrete arch, and you can see that the arch is becoming a lot more flatter because with the usage of the concrete as a material, we are a lot more confident by the time the understanding of the bending behavior, the reinforced concrete, all of them had made an appearance by the time we came to the mid 20th century. And again, it's a spandrel arch bridge. Then finally, even in the, you can say, early model, one of the earliest or the earliest example of a suspension bridge is the Golden Gate Bridge in San Francisco, built in 1933, wherein very large lengths was spanned across by single cable. And incidentally, a lot more challenging about this is the fact that how they build these cables in those days. And size of these cables are all marvelous engineering activities carried out almost 100 years back. Coming back to India, we had a very, we call it early modern bridge, but the foundations were more traditional, what do you call it, masonry structure, and the superstructure was a early modern steel plate girders and no concrete deck at all. Of the railway bridge across the Pamban, which crosses from Ramesh to it goes to Rameshwaram from the mainland. It's a distance of about 3 to 4 kilometers. It included one swinging span, which you can see in the picture here. It actually opens out like the wings, and the opening mechanism is so well engineered that a labor of 2 or 3 people on either side are capable of lifting the whole span. It doesn't require complex power or anything. And remember, it was engineered and built about more than 100 years back. Sad to say, this bridge is going to get abandoned shortly. The new parallel railway bridge is seeing trial runs, and it has also got a lift span instead of a opening span for the navigational purposes. So soon this bridge will be totally decommissioned. So it's something that we can see in terms of the the bridge development in India. And this is the very famous Howrah Bridge. If I were to ask you, what kind of bridge is this? Those from Calcutta? It is not balanced. Let's put it that way. It is not balanced, but it's a cantilever bridge. You're right in the sense, because once you say balanced cantilever, it would mean that both the sides are of equal weight, which is not quite true in this case. It's an unbalanced span. However, it is a cantilever construction, which essentially means that the erection of this started from this side, and finally ended up in a closure in the middle. And you can imagine this is also nearing 100 years of age in a modern. It's a truss at the same time built by a cantilever method. Now coming back to the modern bridges, we are also becoming sensitive to ecological requirement, and an example of a eco-sensitive bridge where you had forest on both sides and a highway going through in between. Highway is also necessity while allowing access to all the animals and creatures that need to cross from this side of the highway to other side. Also, a bridge has been made with all the greenery included on top. This is good, and this was built about 40 years back in Holland, but we are not too far behind. In our Delhi Mumbai Expressway, we also have what is called as an animal overpass, which is not yet greened yet, but eventually this whole underpass has a soil cover, has slopes, greenery will be installed, so that, and this is actually going through the part of Ranthambore Tiger Reserve, is expected to provide for easy crossing of these waterways, and others are the crossing paths of the wild tigers. So they will use this to cross eventually when it gets completed. And to prevent their ingress and egress, they all have the safety fences which will continue to prevent those wildlife creatures to come onto the expressway. So while the expressway will go underneath, the animals have a way to cross across. So in India also we are catching up. We are catching up on these concepts, making structures which are suitable to the local environmental conditions. Then the pinnacle of modern bridges is actually the suspension bridges, and this used to be at that time very, what do you call it? We can call it the talk of the world in bridge engineering in the late 20th century, primarily because of the span, which was almost less than about 2 kilometers long. But this is no more the longest suspension bridge. The longest suspension bridge is today is actually in excess of 2 kilometers. and I'm talking about the span from pylon to pylon. And there is a plan to even build a bridge in Europe, which has got a pylon to pylon distance of almost 3 kilometers. So all these are advances taking place in the field of bridge engineering, which will require a lot more of research, both in the material side, analysis side, construction side, all of it will put together. Then coming back to the types of bridges. Now we had this transition. As I told you, we saw the calendar-wise transition from natural material to semi-natural material to purely man-made material. What helped this transition across was actually three aspects. The first and the most important of it was all the improvement in the material. We started to move from natural material to man-made material, which thereby we were improving the availability, and we were also making sure that the materials were strong as well as ductile. Okay, that is the first improvement which helped us transition from, say, stone masonry bridges towards concrete, and then cast steel, then to steel, and then to reinforced concrete, then to prestressed concrete, and then to cable supported bridge. All of this was basically the improvement in the nature and the quality of the material that we used in the bridges. The next phenomena which helped us was to understand the improved analysis and design tools. We started to understand the behavior of this material and the structures better. As I told you, the first earliest of the so-called, we call it as a classical era, most of the bridge construction was done on proportional basis. They used to see the nature, and they say in nature compressive load is transferred in this safe manner. Therefore, they used to replicate it. They did have a great understanding of stress, strain, deflection, etc. All that, when it started to be understood in a more rigorous scientific manner in the late 19th century and early 20th century, we started to go to more modern forms of bridge design and bridge construction and things like that. And finally, off late, what is driving the transition to newer and newer forms of bridges? The construction technologies which are coming up at a very rapid pace, both in India and abroad, and which is giving us a chance to do much more, what do you call it, different types of bridges, if you want to put it that way. So the transition is helped by material, behavior understanding, and construction technology. Now, when you look at material availability in the prehistorical, we generally had wood and natural stone as the bridging material. By classical time, it became masonry. By Middle Ages, it was masonry, and to use the word steel is wrong, maybe iron is better. In the early modern, masonry, steel, and concrete. And in modern time, it's invariably steel and concrete. Masonry has been phased out, you can strongly say. And the materials were gradually moving from brittle material, weak material, to stiff, strong, and ductile. All these properties slowly kept getting improved from the natural stone onwards till steel and concrete. So this is one transition which helped move from bridges of certain type to what we call as the modern bridges. In terms of materials, this natural rock out, it gives an idea of what a bridge should be, shape, etc. This is what was the earlier thoughts about. This was the first material that was used in a bridge. Then we moved on to dressed stone arches. As you can see, the stone arch. The idea came from this. You can see that this arch-like phenomena naturally was standing safe and sound, and that is what gave idea to the early bridge designers to go in for laying out dressed stone in this fashion. And the most important, what we call it, component being the so-called the keystone, which is the placed at the corner to exactly match. And if that is not placed properly, this arch doesn't work. This was also understood over a period of time as a practice. But most of it, this stone arch bridges came with an idea from a natural occurring like this, something like that. Then, if you notice in this, we were still relying on compression as the main force transferring mechanism. So the arches were very tall. And what would this mean? That means that if there is a level here and a level here, one had to climb a lot in order to achieve this arch behavior. One needed to climb a lot and then come down again. This was modified by going in for a both flatter as well as multiple arches, because the force transfer mechanism was understood a little better, and the balancing out of the force and the large outward thrust being balanced by the buttresses at the two ends of the bridge. This was understood in the next stage of transition from a single arch to multiple arch, and from the multiple arch to multi-storied arches, as you have seen in the aqueduct. And then finally, we started to go for flatter arches, a shallow rise, because this became important for us so that we don't have to climb up. Because remember, these are all in an era when there was no mechanical vehicle. So if you build a crossing, no problem, but it had to be humanly possible to cross it. So if you make it too steep, it will be used for very limited purpose. So therefore, in order to make it more easily accessible, for smaller spans, people started to attempt shallow rise. Again, understanding the load transfer mechanism, creating the right kind of a buttresser. And an example of it is a viaduct that are available in India too. India has got almost a lack of these masonry type of arch bridges. They are almost 70 to 80 years old. So there are great doubts about their residual life. So a lot of them are likely to get replaced in the near future to keep our railway lines in operation. However, many of them are still robustly strong. Their biggest challenge has always been their performance in dynamic situation. As you know, understand that all railway load creates the dynamic loading, and under dynamic loading, all these joints are susceptible to gradual opening out and loosening due to the cyclic loading nature. So whether how good are these joints still performing is a big question mark. So there's a big exercise that will start or has already started in replacing these very old masonry bridges with more modern reinforced concrete or prestressed concrete bridges to keep the railway line still functional. Then you have arches which we started off as a single use bridges. Then we started to use multifunctionality, in which we ended up having a transportation problem solved below a bridge, and we had a recreational purpose at the upper level, which can be used as a viewpoint, passing time, leisure time, etc. Okay, so gradually human beings started to expand the scope of the bridge itself. Then from the one natural material like stone, we started to use natural material like wood also. These kind of bridges were they were called informal light bridges. When I use the word informal, it essentially means you will not find any detailed held calculations for the force transfer, etc. But they had what is called as a proportionality rule. They knew how much is the tension force, and they also knew that when you have this much load, there will be a tension force here, and to balance that, you need to have a strut, and that strut needs to be anchored strongly into the ground to prevent this from slipping down. How deep should this vertical post go? All these were kind of rule of thumb based, very strong thumbs. Okay, so calculations nowadays, if you want to do it, a modern world is a little more different. You may have to do first principle based calculations. The wood became one of the means of bridge construction, though not for major one. For smaller one, they became the next choice of material for smaller crossing. Then wood and rope in combination became a connectivity issues, especially in remote places where you had valleys to cross, small valleys, small fast flowing river to cross. So these were used again in semi-formal fashion in terms of experience and judgment based arrangement. Afterwards, when the wood use became little better known, then the wood became an engineered solution. When I say engineered solution, means it started to get used as a part of truss. It became part of a structural arrangement which could take both tension and compression. Then they started to use logs and planks as walking surface, and logs to carry the tension and compression part of it. So they had that joinery became an important issue, and then the similar ropes and wood combination were used. And then when joinery became important, how to make a precision to retain earth, to make sure that these compression lines are joined together, the wood is abutting each other, the how to give the tension connection when it is there in the wood, etc., became important as well. So joinery became, so this has become gradual progression from a natural material to an engineered material for bridges. So wood became the first engineered material for bridges. When I say engineered material, it means there's a human intervention from its natural form and for altering its normal load transferring mechanism to provide it additional functionalities. So it became sometimes critical link in small stream crossing like this, and sometimes it is also used to prevent what we call it protective measures. A wooden bridge with canopies to cover to prevent snow accumulation, so that at least on the bridge crossing portion there is no accumulation, which can make the bridge be designed light, so that with all this canopy the snow will all fall off, and the snow on the approach road can always be cleaned manually, and it is on the embankment, so it's not a great danger from loading point of view. So wood was used as a engineered material for some time, generally for small bridges, small crossings. With the arrival of steel, most early long span bridges were all made in steel, and quite often with arch-like construction, as you can see in this example, and arch with spandrels and a deck which is having a conventional truss as a load-bearing member. And you also started to see other forms like arches. You have trusses, arches, through arches. All these started to become a part of the bridge construction with the arrival of steel. So in terms of transition, we moved from wood, stone, timber to steel first, and afterwards when the discovery, or I should say invention of concrete, it became the dominant choice. It became the dominant choice. Though concrete is a brittle material, it still became a dominant choice because of its cost equation, because of its ease of production, ease of forming into different shapes and geometries, and transportation became also big easier issue. You need not have it. If you had wood, you had to select the right kind of wood from a deep forest, bring it to the place of necessity, and do all the work. Whereas concrete became a choice of material because it offered all the flexibility in both the construction, usage, location, etc. Okay, so does it mean that we have ended our search for newer material? No. Today, concrete is the dominant choice in spite of it being brittle, but their search is still on for materials that are stiff, strong, and ductile. That search is still on. Maybe in few years' time, concrete would be talked about in terms of history, but until the cost equations are right, concrete will still remain to be the dominant material in bridge construction. Some of the brittleness was solved by introduction of the pre-stress concrete, where we have stresses induced opposing the live load stresses, so that it increases the flexibility, makes for construction of longer span using concrete. Otherwise, with reinforced concrete, we could go only so far. The bridge deck became very heavy and very stiff, and we wanted flexible structure. So in that case, you ended up having to do longer span. And when you do the longer span, the concrete as a material was not sufficient. Then pre-stressed concrete was uh, identified and invented, you can call it that way, and that became a kind of a support medium to the regular concrete. So we have seen the gradual transition of bridge forms due to the change improvement in the material side. Now we started to understand the load transfer mechanism, structural behavior aspect, and improved analysis design tools. So initially we understood only arch behavior. From there we understood the beam behavior. From there we understood the truss behavior. Then we started to understand the suspension cable behavior first. And then we understood the pure cantilever with the no support at the end. Then we understood the box behavior when we started to look for torsional resistance. Then we introduced pre-stressing behavior to understand introducing ductility and flexibility with the slender section. And finally, we have reached a place where, please remember that suspension cable came much before stay cable. Stay cable is our modern day, what do you call it, understanding of structural behavior, which incorporates aspects of truss, aspects of suspension cables, and aspects of bending behavior. Okay, all these things put together took us to a level where we are able to do stay cable bridges nowadays. All right. So this also led to different types of bridge construction as we started to understand the structural behavior, and the theories of structural mechanics and material mechanics started to get formulated. We will move on to understanding just bridge components, and we will stop for the day. We'll continue it in the next class. In the bridge component, you have 5 major components. We all have superstructure, which carries the live load. We have bearings, which transfer the load from the superstructure to the substructure. Then we have the substructure itself. We have foundation, and we have the soil. So these are the 5 major components of a bridge structure. You might be wondering why soil is a component of a bridge system. You will understand that a little later when we cover the aspect of the load transfer mechanism and the soil structure interaction aspects, etc. But without understanding soil, it is impossible for you to do a bridge design fully. So after this, the question to be asked, now if you look at it, that was in the transverse section. If you have in the longitudinal section, you basically, apart from this that we missed out, additionally is an abutment at the end of the bridge, which we treat is like a substructure, and an embankment which is on the earthwork. So substructures could be piers or abutment, and foundation could be shallow or deep depending upon the nature of the soil. Okay. We also have other miscellaneous components of bridges, which we will talk sometime in the other classes, which are basically parapets, which are to prevent accidental falling off from the bridge of the vehicle, live load, passengers, pedestrians, etc. Fenders, which prevent impact of any floating body onto the substructure and foundation if it is a water bridge, or sometimes even on a road if we want to prevent accident. If this is a road, impact of vehicles, we can have fenders. And we have expansion joint devices, which we will deal with separately later on when we talk about the various phenomena associated with bridge deck behavior. So we have all this. So a system of a bridge consists of all these 5 components. Now, which is the most critical of them all? Bearing. Okay.
Everything, sir.
Huh?
Every part of the structure is important, sir.
Yes. Anybody agree, disagree with that? They use the most critical one. So I got one answer as bearing, one answer as all of them are critical. Anybody else differing opinion? Third opinion?
The foundation.
Okay, so one believes foundation is the most critical. Then?
So soil.
Soil. Okay. Okay, they are all components. So you believe soil is the most critical. Okay, fine. So I have 4 opinions. So that means somebody believes soil is the most critical, somebody believes foundation is the most critical, somebody believes bearing is the most critical, and somebody believes all of them are critical. Any other view? Any other view? Okay. So the person who answered all is right. There is no component of the bridge which is not critical. You cannot say this is more critical, this is less critical. All of them are critical. So you need to have a clear understanding of every aspect of every component of the bridge structure before you come up with a good solution. Okay. So we will see the components of the bridges, load transfer mechanism, merit, demerit, option sum, etc. for each step in the subsequent class. That's it for today. We are at 5:30. We have exactly about half an hour's time for any questions you might have in this or related subject. The floor is open to you. Don't let it become 30th January at 11 a.m. Do you know what happens at 11 a.m. on 30th January every year? Oh, even for that, it is 30th January 11 a.m. Yes? What's on 30th January? Every year.
गांधी जी का पुण्यतिथि.
Okay. So what do we do?
2 मिनट का मौन धारण.
Exactly. आप सब लोग मौन व्रत धारण किए हुए बैठे हैं. मैंने सबसे पहले बोल दिया था कि इसमें कोई बॉस जूनियर नहीं है. आपका जो भी डाउट, क्वेश्चंस, दिमाग में कुछ सवाल उठते हैं, इमीडिएटली पूछ लीजिएगा, क्योंकि आस्क, रिमेंबर द आस्क प्रिंसिपल. ओके, साइलेंस विल गेट यू नथिंग.
सर हम ब्रिज का जब हिस्ट्री आप अभी बताए तो ब्रिज का हिस्ट्री स्टार्ट हुआ स्टोन आज से और कंप्लीट हुआ प्री स्ट्रेस कंक्रीट की तरह.
कंप्लीट नहीं हुआ, चालू है जर्नी, अभी चालू है.
मतलब वो जो जर्नी है जो चल रहा है वो स्टोन से प्री स्ट्रेस कंक्रीट, और कंक्रीट के पीछे रीजन बोला गया कि स्टीप, स्ट्रॉन्ग एंड डक्टाइल. पर सर रिसेंट में जितना मैं तो ज्यादा देखा नहीं हूँ, पर जो मैं देख रहा हूँ सर, जो पुराना बना हुआ ब्रिज है, जो अपना मतलब ब्रिटिश में जो बना हुआ ब्रिज है, उसका जो लाइफ है वो अब बनने वाले ब्रिज से ज्यादा अच्छा है. जैसे मैं रहने वाला हूँ रायपुर का, मेरा जो मास्टर हुआ वो नागपुर से. जब मैं नागपुर से रायपुर जाता हूँ तो बीच में कई ऐसा ब्रिज मिलता है, आज ब्रिज रेलवे का या सॉरी अपना हाईवे का, वो ज्यादा स्टेबल है. और रेदर अब जो बन रहा है ब्रिज वो उतना लंबा चल नहीं पा रहा है, जबकि वो ब्रिज बना हुआ है वही मैसनरी आज. तो आपको इसमें क्या वो लगता है, रीजन क्या है?
Okay, I will ask this question if I thrown open to the rest of the class. Do you agree with him that the older bridges, that is the British era bridges, are stronger and more long lasting than the new bridges? So are you telling the modern steel is worse than the olden steel?
सर हम ये बोल सकते हैं क्या कि ओवर डिजाइन है?
मैं आप लोगों से सवाल पूछ रहा हूँ ना पहले, फिर उसके बाद हम आएंगे उस आंसर पे. So what do you think is do you agree that the older bridges are more, basically the observation was they were longer lasting than the newer bridges? Correct me, that's the first part.
Yes, sir.
Second thing is they are stronger than the newer bridges. These are two different aspects. One is depending on the life, other is depending upon the strength. So if I were to ask this question to you, do you agree that they are true, they last longer?
Yes.
How do you know the modern ones will not last longer? Don't give me the example of the 9 bridges in Bihar. Okay. that is not the reason to say that modern bridges are all going to collapse like that.
सब कोलैप्स नहीं है, पर फिर भी सर जो मतलब यदि हम देखते, मैं जिस रूट का बात कर रहा हूँ, शायद आप यहाँ 20 साल काम किए, आपको ज्यादा अच्छे से क्लियर है बॉम्बे रीजन से।
मैं 10 साल भोपाल में रहा हूँ
जी,
छोटी उम्र में। When I was a small boy, I started my schooling in Bhopal, so I am little familiar with Bhopal, Nagpur area. But my question to you is that statement that the older bridges, say British era bridges, were more long lasting than today's bridges?
सर वो एक पक्ष में बोला जाए तो वो सही भी है, और दूसरे पक्ष में नहीं सही इसलिए है क्योंकि ब्रिटिश का जो एरा था वो 200 साल का था, 200 साल अपना पार हो चुका है। जो नया जो एरा बना है वो अब का है। अभी के लिए अपने को फिर अगला 200 साल वेट करना पड़ेगा कि हमारा बना है ब्रिज अटल सेतु 200 साल तक जिंदा है या नहीं।
Okay, then in that case, let me ask, if that is the case, why don't we continue to build Roman arches? You remember the what is that, 14 AD? Yes. 47 BC to 14 AD, the arch water aqueduct that was built by Romans in Spain. I showed you the photograph. Shall we build all the bridges of that nature?
No, sir.
Why?
No, because of the material availability, and like when we see the older structure, it used to consume a lot of area and lot of material, lot of workmanship, and the older bridges might be strong and long lasting, but it might not have been designed for the loads which have been come in the newer generation. Like we have 70-hour loading, which might not be like, it is a
okay. Like so if I have to summarize your observation, the older bridges consumed more material. One statement. Yes. But it strengthens, as far as the loading is concerned, it strengthens Millen's observation stating that after 1,000 years, it is still semi-functional. You may not carry 70-hour loading, but it is still good enough for carrying the water it was meant to. So
at that time it was good, sir, but I'm saying for the modern condition, if I want to use that bridge for the current loading, it might not be feasible.
Safe. It may not be safe. Okay. Or alternative, if I have to design a structure of that arrangement for the modern loading, it will consume a lot more material than it consumed then.
Yes. And that there we have that economic problem.
Yeah. Okay. So ultimately, there are answers within all your observations. The fact that we were replicating nature in its load transfer mechanism. Human beings, we learnt our engineering by observation. We saw the natural arch-shaped structure for an eroded rock, and we found that possibly is a good mechanism for load transfer. So we replicated that. And in the process of replication, we ended up also looking at the natural proportions, that if I have this much span, I must have this much depth. That's all the rules there were. That's all there were. And if I had this much span, this should be a circular one. So if I wanted to cross a 20-meter valley, just as an example, then I need to rise by 10 meters. These were the proportion of those there. So what they ended up doing was, they ended up making bridge construction difficult. That is why, because this bridge construction was more expensive, this type of bridge construction was more expensive, you might have realized that in many of the very old roads in India, we have causeways. Correct? You know what a causeway is? Has any one of you seen a causeway? None of you have seen causeways.
सर वो आर्च टाइप का जिसका
ना. Causeways are what is called as submersible bridges, in the sense, in peak rain, it will be overtopped by water. After the rain goes away, the so-called pathway will open out again. It is very low level bridge. Now, why did we do that? The idea was again the economics, cost benefit effect. ठीक है, साल में 4 दिन के लिए बारिश होगा, मेरे छोटे छोटे ब्रिज के ऊपर पानी जाएगा, मैं 4 दिन के लिए ये रिवर नहीं क्रॉस करूंगा, तो पानी का स्तर कम हो जाएगा, मैं क्रॉस कर लूंगा. That choice was more economical than building a high level bridge, because high level bridge in those days we only knew to understand arches, and they needed such a great amount of filling material, the level will go up, you need to have a long approach. Those were the constraints. So many of them were not built, because even in that era those kind of arch bridges were very expensive. And in railways we don't build submersible bridges. I'm talking submersible, I gave you as an extreme example in roadways. In roads, a lot of old roads have submersible bridges, but I'm puzzled that you have not. Okay, so maybe the reason is you have not gone to relatively less developed areas. No, rural areas, villages.
हाँ सर, वहाँ है ऐसा.
हाँ, क्यों बनाते हैं? यदि इतना आसान है 100 साल के लिए पुल बना देना, अच्छा है, क्योंकि पुल बहुत बनाना, उस जमाने के पुल बनाने बहुत महंगे पड़ते थे.
जी.
So it was not economical. So, but what is our purpose of an engineer? How are we different from scientists? This is my favorite question. What's the difference between an engineer and a scientist? Okay, science also is to a large extent practical, but we are application oriented people.
Scientists invent things. Engineers optimize things.
Oh. Okay, let me put it this way. Engineers tend to use science for public utilization at the least cost. If you don't have the cost figure, we are not engineers, we are scientists. Those of us who hold the opinion that no, we should only do the most expensive solution, then we are not scientists, we are not engineers. We are all scientists, because scientists don't care about cost. They don't talk about risks. We are willing to take risk. None of our materials are perfect. Do you believe all the materials we use are perfect?
No sir.
Concrete, is it a perfect material?
No, sir.
No sir.
What's the problem with it?
Sir, like every time you mix the concrete, like today you mix the same concrete, tomorrow you mix the same concrete, you might not get the same result.
Why? That
Because
for me,
the
for an engineer, believing that is a very dangerous thing.
Yes, sir, it will be, because the workmanship is a factor. The material we use is a factor, because we cannot engineer, like we use a steel which is a industrial made material, but concrete is not that.
Okay, so I understand that heterogeneity, I can understand, but why do you think we cannot get the consistency? Consistency
we get, sir, but depends on the material we use.
I'm talking, workmanship let us talk about M30 concrete to be produced in Karnataka from a single source.
Yes.
Can I get consistency?
Yes, we can get.
Should we get consistency?
We should get, sir. As an engineer, we should get, but I'm on site aspect.
The point, I understand the point you're trying to make. How we are not using material whose consistency we can guarantee. But as engineers, we are still willing to take the risk. Why? Because in all our design principles, which we'll see in subsequent classes, how these design principles are all formulated and what's their background behind it. In all these design principles, we have built in what is called as margin of safety for uncertainty. But that uncertainty is to some level. It is not for totally chaotic uncertainty. Certain things must be well defined and in control. But there are certain things which can vary, because all of them are, as you have rightly pointed out, they are all operations which are not so precisely controlled. But today, if you want to ask me, only in very unimportant structures do we do hand mixing of concrete. Where have you seen last the hand mixing of concrete recently?
Nowhere, sir. It was only in the college labs.
College labs. Otherwise, what do you see?
We all see the RMC one only, sir.
Where is RMC produced?
Actually, I don't know, sir.
You don't know?
No, it
I
is a
think-
factory thing.
So it's a controlled environment.
Yes.
And it has got all kinds of calibrated mechanisms to control the inputs, in whether it is sand, cement, aggregate, plasticizer, size of aggregate, moisture content. All of this is automated, correct?
Correct.
So you should get a consistency.
Yes.
Do we get the consistency? We'll come to that some other day. One of these spare days, I have a presentation that deals with something that we bridge engineers don't want to talk about. Basically, bridge failures. We'll do that one of these classes. In between, when we are bored of too much of technical stuff, we will talk about fun stuff. So the progression has taken place primarily because we are all being practicing engineers. We want to stretch our material as much as is possible. So stretching the material as much as is possible, is it morally good or morally bad? Socially good or socially bad? Philosophically good or philosophically bad? Yes? What would you like to do if you have got 1,000 rupees in your pocket? Would you like to spend it on little or try to get as much out of it as possible?
Use it completely with little margin of saving.
But still get as much, maximize your benefit.
Yes.
Correct?
Yes.
So why is it that you look at it wrongly when it comes to utilization of material for structural purposes? So the point is, the olden bridges lasted longer for two reasons. One, they had not been subjected to the design load they had actually been designed for. Second thing is, they utilized a lot more material than was necessary. Does that mean that our modern bridges are going to collapse? No. Our modern bridges fail primarily because along with any optimization comes quality control requirement. We are constantly forgetting that aspect of it. We ignore it and we end up paying the price for it. Okay, so it is important that to understand that the progression of the bridge design took place primarily to stretch the value of the money in our pocket. If we have deep pockets, every one of the bridge will be the most fantastically designed bridge. Because we want to provide connectivity to as much places in our country. I'm not talking about this as true for India alone. It is true for every country. Every country tries to say nobody likes to waste money nowadays. Everybody wants to stretch the money to as much as is possible. And that is where comes to the crux of the whole issue. Why engineers are different from scientists. Engineers like to keep an eye on the cost. For scientists, it's an absolute truth. For us, it is relative truth. It works. If it works efficiently, it's good enough for me. A solution will not be picture perfect, but I understand the extent of risk that I'm taking and I understand the consequence of it. Tomorrow, in future classes, when you talk about load factors, what do they cover? The response reduction factor for earthquake, what do you cover? When you understand those concepts, you will understand where the concept of safety and economy and reliability comes into the picture. How we try to balance it out as engineers and take a decision. Okay, what else? I'm not hearing from everybody. I would like to be more participative. Okay, I need one more thing. I need a one-point contact for dissemination of information within this group. I don't want HR to be totally involved in it. So among you, I want you to select somebody to whom I communicate and he will communicate to the rest. Who shall it be? You elect. or you sell it, whichever way works for you. All hesitate.
सर मैं कोशिश करूंगा अपनी तरफ से सब बोलने के लिए।
नहीं, एक बार डिसाइड कर लिया तो you have, what are your requirement from my side? Your requirement is to make sure that everybody gets a reminder. There's no need for it, but they should have it in the calendar. Akhtar Nadeem has nominated Milind Gaur directly. So and you also volunteered. So you need to make sure that these sessions will have recordings. So I am not going to take the recording. I want one of you to do the recording. Recording should be stored in a place where the 11 of you who are participants access it. Okay. And as and when I give you the assignment, I give it to you. You circulate it among, and they will all give their answer to you, and you on the prescribed date pass on the bunch to me for my evaluation. These are the kind of activities. Somebody who coordinates the interaction between the group related to this training program. Is it okay with you? You'll have time for that?
Yes, sir.
Okay. In which case, what you need to also do is you need to, with IT people, why recording is not permissible? I'll ask HR, I think. Are you sure recording is not permissible?
It is, sir.
Like you mean to say I am the only one authorized to record?
No, sir. We can record it, sir, but with your permission. That we can record,
okay,
we can record.
You as I told you, I am not bent on formalities. Okay, I have said recording should be there so that you can go back and refer to it as and when required. So, but the point is, you do the recording, you store it in a place where it's accessible to this group. That you find out with your IT people, because it will be file size might be significantly large. Okay, so that you will be able to have a storage space which is not going to clutter up your own desktop. I don't want you to keep it anywhere in your own machine because it will just use up your memory like anything. Find out with IT people. So that bit you have to do the interaction and get it sorted out. Okay. Yes, Milind?
Yes, sir.
Okay. So have you unanimously agreed to Milind as your coordinator?
सर एक चीज बोलना चाहूंगा, ये जो रिकॉर्डिंग होगा वो मतलब मेरे पास जो सिस्टम है परमानेंट सिस्टम नहीं है, तो सर वो उसको असाइन कीजिए जिसके पास परमानेंट
सिस्टम। बोल रहा हूँ कि आप अपने आईटी वाले से बात करके पता लगाइए कि ये जो रिकॉर्डिंग है इसको कहाँ पे स्टोर किया जाए ताकि आप 11 लोग उसको जब चाहे एक्सेस कर सकें।
जी सर, बात करूंगा।
ठीक है। ओके, बाय द वे आई एम सॉरी, आई am talking occasionally in Hindi. Is there anybody who has problem with Hindi?
Yes, sir. I'm.
Okay, I'm sorry about that. I will try not to take the conversation in the Hindi direction because I see most people should have no problem. But yes, Bagarni, you didn't join in the early part when the introduction was going on.
Sir, that cable stayed presentation is streaming in Chennai office. Initially, they didn't mention about this presentation earlier at morning. So
no, 1 second.
I waited for that.
Now it is there for all Fridays 4 to 6.
Yes, sir. Previous Friday it is postponed. So I think
that was because I had a presentation to make in that workshop. So
yes,
that is why I couldn't. I had asked Nidhi to start it 1 week later. I am not attending the rest of it.
So initially I joined there. After that, I get the notification. After that, I skipped that
presentation and the job.
Okay. All right. So in that case, in the beginning, I had asked all those who participated to switch on their camera and introduce yourself. So you can do that now, so the rest of the group know. Yes, go ahead. You're mute.
Yes, sir.
Yes.
Good evening, sir. I'm Bhavadarni. I'm an engineer from structure infrastructure department. I'm working in Chennai office here.
Where did you do your studies?
Yes, sir. I completed my master's in College of Engineering, Guindy.
Okay.
Yes, sir.
And you are in this company from when?
2022.
Okay, fine. Right.
Yes.
Did we miss out anybody else in the other session? I think Shubhajit. Akhtar also, you didn't introduce yourself, if I'm not mistaken. You were not there in the early part. Hello? Akhtar? Okay. All right. So we end this session. If you have any further question, we still have time. 10 minutes time is there. If so, otherwise we will meet next Friday at 4 o'clock. Yes? Okay. I think आप लोगों को you like your 30th January a lot. Though your 2 minute silence continues for 2 hours. I think the next time I will make sure that in between I keep asking question by turn. That would possibly wake you all up. Okay? Right. If nothing else, then we meet next Friday, 4 o'clock. All right?
सर वो नेक्स्ट सेशन कि में अटेंड करने से पहले कुछ चीज ऐसा है जो अपने को पहले से पढ़ना हो या कुछ नॉलेज की
I had given, no, see, as I told you, the subject is more introductory in nature. My intention is to introduce your topic, stimulate curiosity in you, and then I want you to read on that subject and build up your knowledge. See, let me put it this way. My 30 weeks interaction, 33, 35 weeks interaction with you is not going to give you any expert level knowledge on it. It will be introductory level knowledge. And thereafter, I want you people to pick up on that. I have given certain reference books. You should try to read and catch up on that as much as is possible. I hope Nidhi and others, when they talk to you individually, they did share with you the kind of course content that we are likely to have and the kind of reference books prescribed for this.
कंटेंट के लास्ट में था सर रेफरेंस बुक का लिस्ट
हाँ ना
था सर
हाँ exactly. So but rest assured I can't cover all of it. Rest assured I can't cover all of it. I want to tell you one universal truth about all the courses, all the so-called teaching methodologies. I want these questions to be answered by people who have not opened their mouth. Okay. You all done MTech, right? How were your courses structured? They had some credits, right?
Yes, sir.
They had some credits?
Yes, sir.
What did that credit mean? Do you have any idea? Say a 4-credit subject or a 3-credit subject. What did it mean? Universities, out of their own whims and fancies, fixed that credit, is it? You have no idea how those credits, what did the credit mean? A 3-credit course, a 4-credit course, and a 5-credit course.
It's based on importance.
No, not at all. Absolutely not. Let me put it this way. I am maybe a little brutal, but I'll ask you one question. If you ask me, hydrology for me in the BTech days was less important than basic design of concrete, as far as my current career is concerned. However, the credit for both were same.
तो उसमें लेक्चर और प्रैक्टिकल सब, जिसमें लेक्चर प्रैक्टिकल ये सब इन्वॉल्व है, उसका क्रेडिट ज्यादा होता है, जिसमें नॉर्मल
Number of hours.
Absolutely correct. So when you talk about a 3 credit course, it means 3 lecture hours of 1 hour each per week. If there is a tutorial class attached to it, it becomes 4 credit. If you have a lab or physical work attached, it becomes 5 credit. So typically a theoretical course is a 3 credit course, typically, right? 3 hours per week, 3 hours per week. So when you attend a structural analysis course in your BTech level, it must have been a 3-hour course, 3 credit course. So 3 credit course means what? 3 hours lecture per week. How many weeks is a semester? Typically?
16.
15, depending upon the college, 14, 15 or 16. Let us take 16 weeks. 16 into 3, 48 lecture hours per subject, like something like structural analysis or concrete design or steel design. They were all in the same category, correct? So, and what was the size of a typical textbook for each one of these courses? Size in terms of pages.
500 to 700 pages.
500 to 700 pages. Now I'll ask you a simple question. Is it possible to teach 700 pages content in 50 hours?
No, sir.
No.
So what did they teach and what did you learn? And what did you pass? It's an honest question to ask ourselves. We say we passed this course, we got this degree, we passed this degree. When we say all that, what exactly did we mean? So, who should I ask this question? It's a little embarrassing. Maybe who has seen not opening my mouth? Okay, Miss Praful Prasad, you're still there?
Yes, sir.
So what in 50 hours, a 700-page book, can it be taught?
No, sir.
So when we say we passed the course, did you think we passed knowing all the 700 pages worth of information and knowledge?
Not the 700 pages, but basically the major part of that.
And who defines the major part?
The previous year question papers.
So we are coming to the crux of it. We have passed an exam whose structure, whose content we knew from the beginning. So where do we go wrong? So do you think this method of education is right?
Yes.
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 This method is right. Perfectly all right.
No, it is wrong.
सर रॉन्ग है, पर राइट इसलिए है कि यूज उसका प्रैक्टिकल उतना होता नहीं है, फील्ड में ही आके अपने को सीखना है.
Okay, now I'll give you a contrasting example. Okay, all of you have attended your BTech and MTech programs, right?
Yes.
How many courses per semester did you study in your MTech? Per semester, how many subjects were there? Number, how many subjects? 4 to 5.
4 to 5.
All of you agree in that range?
Yes, sir.
Yes,
You
sir.
found it difficult, comfortable to manage 4 to 5?
It's a little bit difficult.
Little bit difficult. Did anybody find it very difficult? Nobody. So everybody found little difficulty. Now I'll tell you my experience when I did my master's in CMU. When I went there, I went with the same approach. I had studied during BTech days. We had 6 or even sometimes 7 subjects in a semester. At BTech level, we tend to have more subjects. I went there with an idea that I can take 4 courses in a semester easily, so that I finish the core subject and I can choose more electives in the next semester. That was my thought. I'm talking about 82 to 84 period. All my colleagues, seniors advised me, don't take more than 3. If you take more than 3, you will die delivering. I didn't listen to them. I registered for 4 subjects in my first semester. And you won't believe I literally died delivering the project professor's expectations, because at master's level, they introduce a subject, and then they give you an assignment with a time-bound delivery. They will say this assignment must be in my mailbox by midnight of such and such day. If I don't see a submission, you get 0 for it. And for 4 subjects, I literally died delivering that. That's another method of touching. You can argue the same. They also had textbooks. They also had all these things. Then you can say, why are they doing this? They also, not all of it is applicable, and therefore they can ask a little bit here and there. The biggest difference was, in India, all our education system is based on giving you facts, asking you to memorize the facts, and reproducing them in a structured examination. What do? They introduce a subject, they introduce some concepts, some, not all. They give you an assignment whereby you spend a lot of time reading up on that subject and absorbing a lot of other concepts. If you have a doubt, you go and ask the professor for clarification, which concept you didn't understand. So what happens in that process is, you slowly learn how to teach yourself. In this practical world, you are going to face a lot of situations wherein there will be no ready-made solution, or at least not known to you from your own personal experience. So what do? There are 2 ways to do it. You may convert anybody whom you consult into a god, and take whatever he says and believe in it. Or alternatively, you can take yourself as a diligent engineer, collects ideas, who studies on her own, compares various alternatives, looks for the best solution from your viewpoint, and take that as a solution path. The second option requires a lot of self-work. And that is what my masters taught me. My masters taught me 0 in terms of new knowledge. What I mean by knowledge is facts. Nothing new at all. All it taught me was how to manage things on my own. And that is one basic lesson I want you to take back at the end of this course, because as I keep telling you, I will not be able to teach you the whole of the bridge engineering in these 30 weeks also. The 30 class is almost 1 semester equivalent, because you calculated 16 into 3 hours, 48 hours is the maximum. We are going to spend 33 into maybe 1.5 hours. So about 50 hours. Very similar to a semester's worth of course material. But do you think I will be able to teach you all about introduction to bridge engineering? Not possible. Not at all possible. So what is my intention then? And what should be your intention? Don't treat it as a source of information. That source of information is already available to you in the form of internet, in the form of soft copies of textbook, in the form of code. All that is available to you. You don't need to attend this at all. What you need to attend this is to get involved in the process of thinking, analyzing, and critical evaluation. And thereafter practice that in your day-to-day life. That is exactly what I want you to. I told the HR that I'm not going to conduct this course as a classroom lecture and things like that. I want people to participate. Ask your question. Please understand, there is no such thing as a stupid question. There is no such thing. There are only questions. There are only questions. There are no right questions. There are no wrong questions. There are only questions. So you should ask. That's why I emphasize the ask principle in the beginning. It requires you to change your attitude. That means you should change your heart, the way you think. You should have the knowledge, the skill which you will develop by practicing, and then you will end up having the knowledge which you will have to develop. So that you will get all that when you practice the ASK principle that I propounded in the beginning. Ask, and not only now, ask next time your senior tells you, you just do it like that. Without telling him to go to hell, you can ask a question. No senior should be like that who tells you, no, I don't have a time or anything like that. Incidentally, I will share with you my first bridge design I did in 84. 85 84 September, they gave me the design. It was the first bridge in my life I did was segmental bridge. I didn't know anything about it. I was doing what is called the Japanese method of learning, which is copying the steps of a previous design done in Stoop. I finished the design by April, May of 85. You know what they did? They bought me a ticket to Chennai and said, go and get it approved from Southern Railway. I went to Chennai. I was how old? In 85, I was 25 years of age. Almost most of your age. What did I have an experience of? Nothing. But just the 1 year, 6 months, 8 months working in Stoop. But they gave me an opportunity to learn from a previous work. I picked up some. I didn't pick up many. When I went to Southern Railway, they asked me many questions which I didn't know. But the difference was they didn't put me down as somebody who didn't know. They were more accommodative in terms of how they dealt with me as a fresh green engineer than what they do. Today's proof checking exercises have a different atmosphere. They try to generally, I get a feeling they try to get to prove each other that I know more than you. There's no point in proving that. There's no way anybody can establish that. It's just an ego trip. So when I got that approval, after I got the approval, I understood that I lack so many things I don't know. I have done certain things. I don't know how it is realized at site. So then I fought with Stoop management. I was all of 25 when I told Stoop management, if you don't allow me to go to site and spend time and seeing how my design is getting built, I will not go for any further approvals. Would you believe it? They booked a ticket for me from Bombay to Cochin, paid for 1 week stay in a hotel there. I spent 1 week in the site during the whole, looking at all the construction aspect, and it was a great learning experience for me. That organization Stoop was like that in those days. Okay, I don't know how it is now. I left it long time back. I'm only getting in touch with that organization again only after the acquisition of L&T Infrastructure Engineering by A Systems. But you should have that approach that your learning shall not be curbed. If you put a barrier to your learning, it should be your own. And if it is your own, then only you can blame yourself. Let nobody else set a barrier to your learning. Neither the organization, nor your boss, nor your colleagues, nor your circumstances. Okay? Let it be so. So in that case, I'm just telling that learning is a different thing than just gathering information and facts. Gathering information and facts, if you do a Google search, you will get 15,000 similar opinions. The question is how to organize them, how to make a cogent sense out of it. That's how you should train yourself. I'm more interested in, at the end of the day, you being able to train yourself. If you are able to train yourself, your rest of the career, you will constantly build up your body of knowledge and experience, which will stand you in good stead. You remember the first graph I showed you between a passionate and the achiever? You must move yourself to passionate, and the passionate one, you will only if you commit time for yourself. Company will give you these 2 hours. They have provided somebody like me to be a kind of a mentor, not exactly a professional teacher either. I'm basically a professional engineer. I know how to do things. I don't know how to teach. Let's be clear on that. Okay. So don't expect me to be like your typical professor, but a mixture of a friendly colleague, maybe definitely a friendly senior, but maybe a demanding also. I don't want you to get into the idea that it's a laxed thing. I can just come sit here for 1 hour and go away. But I want you to, if something triggers in these classes, something triggers a thought in you, do your own study, find out whether whatever has been told is in line with what you have seen elsewhere in your study material, anywhere else, or is it contradictory? If it is contradictory, why is there a contradiction? These are the kind of discussion I want to have. That is how your knowledge will expand. Okay? Right. Shall we call it a day? Nobody wants to say first yes. I can be here till 9 o'clock. No problem.
Yes, sir.
What? You also want to be here till 9 o'clock? Yes? Call it a day?
Yes, sir.
Okay then. So see you all next Friday, 4 o'clock. Please remember my request. I would request those who have no access to camera, please find something which has a video, because we would like to, I can't, at least some of you I was able to see your face of over. It will take time for me to connect voice and face. Okay, I'm not that good at people, so bear with me. So I would like to see occasionally, I'll ask you to turn on camera so that I can see who is speaking. All right. So can you find that? Those of you who are unable to do that?
Yes, sir.
Okay. And Milind, you will do the recording from next time onwards.
Yes, sir.
And you will find out from IT where to store these recording for the others to access. All right.
जी सर, मैं अभी बात कर लूंगा.
Okay then. All right then. Good night, everybody. See you all Friday next.
Good night.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Bye.
Bye.